Hello guys, today I'm gonna improve or optimize my script that I created in the previous video. So let's check it out. vmain.py. So here we are working with files from the file system. We are reading them and writing them, and also we are doing encryption using XOR operation. So I think the bottleneck of this uh, program is this operation encryption actually. So this is the CPU bounded issue. So then since I have to use multiprocessing, I could use multi-threading if it was input-output bounded problem, but I think it's better to use multiprocessing here. Let's measure the time of execution of our function. We can import from time, import time. Okay, and let's create a start variable here. Start time. Okay, this is gonna be our start, and here we will print time, current time minus start. So here this is the way how we will measure the time of execution. So it's pretty simple. And here cd XOR script. I'm gonna create some files here, pretty big files, like let's use truncate. It will be there will be just empty files like 10 megabytes each maybe, and like test from 1 to 10, yeah, to 10, and make it dot file, for example. So we got 10 files from 1 to 10, and they are 10 megabytes each. They are just stuffed with 0 bytes, so with zeros. But it doesn't matter, we just need files for testing. And we can do python main.py and run it. Let's use 123 keyword, and we are waiting when it will be encrypted. It should take several seconds, I think. Okay, it looks like it's done. 16.62. Okay, not too bad, but let's try to improve it. We can do import here. We're gonna use this library from concurrent features, futures, process full executor. Yeah, I need process full executor. Import here. Import process full executor. And what exactly we're gonna put in our processes? We're gonna create different processes and run our encryption in the parallel processes. So I think these 4 lines, yeah, I'm gonna create a different function here, like define like file crypt and file name as input, and paste it here. But here I need to remove this. Okay, it's looking good. So and here I'm gonna create a list with my futures. Futures will be my processes that I will run them all together. So futures equals empty list, and here I'm gonna do futures append, and here will be my Okay, so I have to define first with spool executor like that, as PPE, for example, and list for lines. I did. No, we need 4 lines. Move it like that. Okay, looking good. And here, I'm gonna do PPE submit, and I will submit here my file crypt function, file dot no, crypt function, and file dot name is the argument for the function. Okay, so this loop will go through all my directory, get all the file names, and create the futures for and put them into my list. And now I'm gonna create a new loop for future in also I need as completed here. I can as completed. Is my as completed? What the hell? What happened here? Okay. Here in as completed futures. Okay. And future dot result. Okay, here we go. So what happened here? I created the empty list for futures, and using this process pool executor, I submitted each file as a different process, to my futures list. And here in this loop, I go through this futures list and checking for the result. So it should work. Let's check how fast it works now. Just run it again. 1, 2, 3, the same keyword. Run it now. And we got 5 seconds. So instead of 16.6, we got 5 seconds. We can repeat it one more time just to make sure that it works faster. Yeah, 5 seconds again. So this is how we can use a multiprocessing in Python. There is also another library like thread pool executor, and it may be useful if we have a deal with a lot of operations with input and output, like we are requesting something from the server or writing and reading a lot of files. But since that here we have a deal with this CPU bounded operation like XOR, this is the real bottleneck in my function. If I try to replace this one with a thread pool executor, so it will not work so fast. Maybe it will work even slower. So, and that's it that I wanted to do here today. I wanted to show you how to work with multiprocessing in Python. So that's it, and thanks for watching, and bye.